Good afternoon, sir. Say good evening, sir.
Good evening, Aryan.
Good evening, sir.
Yeah, good evening. Okay, so today we will be doing carbon and its compounds, which we were doing, right? And we'll continue with the bond formation in carbon. First, we'll learn how to make the electron dot structures. Okay, then we'll see the covalent bond, which is formed by the sharing of electrons. So, Moksha, what in the last class we had discussed about the ionic bond. Do you remember what are ionic bonds? Moksha,
Sir, can you repeat again?
do you remember what are ionic bonds?
Sir, ionic bonds is a type formed by complete transfer of valence electrons and attain stability.
Okay.
It's a bond formed with two ions.
Yeah, the bond formed between two ions is formed by the complete transfer of electrons. So ionic bond is the bond formed between two ions, and since the two ions are opposite charges, the two ions they are oppositely charged. So today, welcome all, welcome everyone. Let's start with covalent bond formation. So covalent bond is formed. Yeah, covalent bond is formed between the atoms which cannot transfer their electrons, or they do not have their ability to gain completely the shared pair of electrons. So in such atoms, you have the formation of covalent bond. So let's see. Covalent bond. It is the bond formed by the sharing of electrons. This is a bond formed by the sharing of electrons. Is called as a covalent bond.
Sir,
Yes.
are you sharing your screen?
Oh, yes or not? I hope it's shared now.
Yes, ma'am. Yes, sir. Yes.
So covalent bond, it is a bond formed by the sharing of electrons when two atoms share, when two atoms they are not in a position to either completely transfer or completely again take over the electron. So such atoms they share their electrons or they form the bonds by the sharing of electrons. For example, if you see the bond formation between two chlorine atoms or the bond formation between two oxygen atoms. So let's try to make the bond formation for Cl2 or for O2. To do, since every chlorine had 7 electrons in its outermost shell. So see this chlorine will have 7 electrons in the outermost shell. And its chlorine is also a highly electronegative element. So it's not possible for this chlorine to transfer the electron to the other chlorine. Alright. So the structure which I have made here, it is also called as an electron dot structure, where the electrons are represented by the dots. So similarly here I have taken another chlorine atom, and here again I write the electrons. So do you think that either of the chlorine is in a position to donate its electron and form the bond, or will gain a stability by donating electron?
Sir, it will gain stability by gaining electron.
Yeah, both of them, they will gain their stability by gaining of electrons, and there is no one to transfer the electron. All right. So here, both of them can gain electrons by sharing. You can say that this chlorine will be sharing its electron with the other one, and this chlorine will be sharing its electron with this one. This will give rise to the formation of Cl2 molecule. So the molecule which is formed is like this. You can see the two chlorine atoms sharing one electron from each. So this chlorine, which had 6 electrons, shares one of its electron. The other chlorine, it also has 6 electrons. Okay, and it has also shared one of the electrons. Now you can see the octet of each of the chlorine is satisfied. So this chlorine also seems to have now 8 electrons, and its octet is satisfied. And this chlorine also has 8 electrons. One was its one electron, and the other one was the shared electron. So we observe that the valency of each of the chlorine is satisfied by the sharing of electron. Got it? So this method of bond formation by the sharing of electrons is called as a covalent bond. Here we don't have a positive or a negative charge on either of them. Got it? Since it is just providing a stability to both the chlorine atoms, therefore this bond is formed. The condition for the covalent bond is that the number of electrons that will be shared, or the number of electrons that an electron will gain as a shared electron, will be the same as the number of electrons that it contributes. Alright. For example, see this first chlorine, it contributed 1 electron, so it is also gaining the benefit of 1 electron from the other chlorine. Suppose it shares 2 electrons, so it will get the benefit of 2 electrons. Got it? So this molecule is a Cl2 molecule. So what type of bond is there between the two chlorine atoms? Covalent or ionic? Yes, Abhinav.
Yes, sir.
The chlorine, what bond is there between the two chlorine atoms?
Covalent.
Yeah, it's a covalent bond. So what do you think? Will chlorine be an insulator or a conductor?
Uh, Conductor.
No, it will be an insulator as there are no ions.
Oh, yes, sir. Right.
Since there are no ions, so therefore this chlorine will be an insulator. Okay. Can you show me the formation of O2? Tumok, everyone try to show the formation of
Yes,
O2 in the
sir.
cigarette. Try to
Sir,
show.
O has 6 ions in it.
O has,
6 electrons.
yeah, O has 6 electrons. Okay. Has everyone made O2? Dhriti,
Yes, sir.
have you made O2 molecule?
So I'm just making
And I will check here randomly 3 people are. And if your work is complete, you should be able to show it. So 3 people randomly I will be asking. Okay, see. Dharya, have you done it? Dharya, Rijwana Sheikh, Rijwana,
Sir, did you call me?
yeah, Dharya, have you done? Have you made the oxygen molecule?
No, sir. I had gone for washroom. I was not there.
So that's why I told you to keep your camera on. Otherwise, it seems that you are there in the class,
Sorry,
but you are
sorry,
not
sir.
there. So make the 2 oxygen atoms with their individual electrons. So each oxygen atom has 6 electrons, and each of them it requires 2 more electrons. Since every oxygen requires 2 more electrons, so it must share 2 electrons. If it share 2 electrons, then only it will have 2 more electrons. So see this one. Both the oxygen atoms will be sharing 2 electrons each. So here the 2 electrons, right? Now see, when 2 electrons have been shared by each of the oxygen atoms, now we see that the oxygen atom's valency is satisfied. So you can see that this oxygen, if it has gained these 2 electrons, this oxygen has also gained this electron. So there are a total of 8 electrons with each of them. Hence, the valency of oxygen is satisfied. Now this can also be shown with these 2 lines. So oxygen and making 2 lines with between oxygen. It showed that the 2 oxygen, they are connected with a double bond, or they are sharing 2 electrons. So there are a total of 4 electrons which are participating in a double bond. Rijwana Sheikh, Rijwana, are you there?
Sir, once can you repeat what you told just now?
Just now I told that when there is a sharing of 2 electrons, it means and that there is a double bond between the 2 atoms. Right? A double bond can be shown with the 2 lines. For example, here the 2 oxygen atoms, they are sharing 2 electrons. Okay, so it can be shown with the help of a double bond between the 2 oxygen atoms like this. So in a double bond, we have 4 electrons which are participating. Okay. Rijwana, Rijwana, yes, Rijwana, are you able to speak up?
yes, sir.
Okay, so where were you? I was calling your name, but you're not there. So you have to be attentive, be present during the class. Otherwise, say it doesn't look good if I forward someone's name in the group that this and this person is not responding. Okay. So Rijwana, how many electrons participate in the formation of a single bond? A single covalent bond. Rijwana,
Sir, could you explain the question?
how many electrons are required in the formation of a single bond?
Is it
Or how many electrons participate in the formation of a single bond?
two, sir?
2. All right. The answer is correct. It's 2. How many electrons are participating in the formation of a double bond? So when a double bond is formed, it is formed by the 2 electrons. There are 2 electrons which are participating. The next we see about the carbon atom. Now let's move to the carbon atom. What type of bonds are formed by the carbon atoms? Okay, so let's see what type of bonds are formed by carbon atoms and why. What type of bonds are formed by the carbon atom?
Sir, covalent.
Yeah, covalent bond. Why carbon atoms forms a covalent bond?
Sir, because they share the 4 valent electrons each to the other.
What happened?
They equally share their valence electrons.
They equally share their valence electrons. So the problem with carbon. So the first problem with carbon is that carbon cannot form a carbocation. Can anyone tell why carbon cannot form a carbocation?
Sir, because it belongs to the 14th group, so it has to gain or lose 4 electrons to form an octet.
Yeah. So carbon definitely it can't form a carbocation. For forming a carbocation, it has to lose 4 electrons, and it's not easy for the carbon atom to lose the 4 electrons. Okay. As let's see the structure of carbon. So
Sir,
carbon,
then it can not form a carboanion also, no, sir?
yeah, first we look up at the carbocation, and then we look for anion also, carbon anion also. Okay. So you see here, carbon cannot form a carbocation. The reason for not forming a carbocation is that carbon has
Sir, then how will it be
protons.
represented, sir? Like,
Yeah,
then how will it be represented, sir? Like, we have Na plus, no, sir?
yeah.
Then how will carbon be represented?
It won't be represented as it cannot form a carbocation.
Okay, sir.
So it can't form a carbocation. Carbon has 6 protons, and losing 4 electrons would require large energy. So for such a big amount of energy, for a large amount of energy, it's not possible to have that much amount of energy being applied and breaking all of them. So before that only it will cause the dissociation. Okay, so carbon cannot form all carbocation. That means if it loses 4 electrons, so if it loses, even if it loses 3 electrons, the hold of the nucleus on the other 3 electrons will be very high. So the nucleus will be holding out the electrons very tightly towards the electrostatic forces of the nucleus. That is why carbon cannot form carbocation. Also, the second point of problem with carbon is that it cannot form carbon anion. So why carbon cannot form carbon anion?
Sir, gaining four electrons will be difficult, no, sir.
Yeah, it
For
will
the
be
atom.
difficult for the nucleus to hold the 4 electrons. So carbon cannot form carbocation as it will be difficult for a nucleus of 6 protons to hold 10 electrons. Alright. So a nucleus of four protons, it can't simply hold out 10 electrons as the electrostatic repulsion between the nucleus, between the electrons will be very high. Okay. So it won't be stable. And therefore carbon cannot hold 10 electrons. So carbon cannot form a carbon anion. Oh, carbon anion. Sorry, I have written a carbocation again. Okay. So carbon cannot form carbon anion as it will be difficult for nucleus of 6 protons to hold 10. Got it? So the only way with carbon is that it can form covalent. Since its valency is not satisfied, so carbon can form. Therefore, we have carbon forms covalent bond. So the solution to the problem is that it can form bonds by the sharing of it. You see, how does carbon form bonds by the sharing of electrons? We will see here the formation of CH4, methane. We will see the formation of CO2, carbon dioxide. Okay. We'll also see the formation of C2H2. So first we'll see the formation of CH4. As we know that every carbon has 4 electrons in the valence shell, and hence to form its molecule, the carbon must form 4 bonds. So here the carbon should form 4 bonds. All right. So with carbon, this carbon will be forming 4 bonds. So it will be like this. To complete it octet, it has to form 4 bonds. It has to share 4 electrons. Since every hydrogen can share at the most only 1 electron, because hydrogen has only 1. So hydrogen will be sharing only 1 electron. So this is hydrogen, 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 and hydrogen. So here we will have hydrogen, 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 and hydrogen. Got it? So you can see every carbon sharing 4 electrons and hence taking the benefit of 4 more electrons from each of the hydrogen atom, giving rise to the formation of methane. So you will have like this, you will have carbon bonded to, you have carbon bonded with 6 of the hydrogen like this. Hydrogen, hydrogen, hydrogen. So just remember that a carbon can form maximum of 4 bonds. Okay, or it will always form 4 bonds. Alright. So here it has formed 4 single bonds with each of the hydrogen atom, giving rise to the formation of methane. Okay. Try the formation of CO2, carbon dioxide. Yes, try out the formation of CO2. Okay, anyone got? Okay, has anyone made the CO2 molecule? Carbon dioxide?
1 minute.
Abhinav? Yeah, Abhinav, have you made?
No, sir.
So try to make. And please put your cameras on. Put your cameras on. Dhriti, Sudhamshu, Abhinav, Dhairya. Is Rijwana there?
So once can you show it, sir?
Which one? Which one do I need to show?
Yeah, mine.
It's here only. Okay, if you want carbon dioxide, let's see. I hope you want to see the structure of carbon dioxide. So for carbon dioxide, I make a carbon atom.
On the both sides, right?
Yeah, there should be 2 oxygen atoms. And since every oxygen atom requires 2 electrons and carbon requires 4 electrons, so carbon will be sharing 2 electrons with each of the
Sir,
oxygen.
like this.
Yeah.
1 minute, sir. I drew the structure.
Okay, just 1 minute.
It's a double bond, right?
Yeah, there will be a double bond. There will be a double bond with each of the oxygen atom. Rijwana, are you getting how to draw these structures?
No, sir. Can you explain it?
Sir,
Yeah,
like
so
this.
okay, just 1 minute. Okay. But you have made just one bond. You have to make the carbon atom will be no, it's not correct. Okay.
Okay, sir.
How is the valency of carbon satisfied? Is the valency of carbon satisfied?
No.
Carbon should be forming 4 bonds.
Okay, sir.
Okay. So check carbon should form 4 bonds and oxygen should form 2 bonds.
Okay, sir.
Okay. Yeah, Rijwana, see here. Everyone see here. So this carbon has 4 electrons around it. And now we will write oxygen atoms. So 2 oxygen atoms on either side and every oxygen atom consisting of 6 electrons. So see 6 electrons. 1. Okay, we make it again. 1, 2, 3, 4, 5, 6. Again 1, 2, 3, 4, 5, 6. Alright. So Rijwana, how many electrons are required by each oxygen?
2, sir.
2. And how many electrons are required by carbon?
4, sir.
4. So see, each oxygen will be sharing 2 electrons. So this oxygen will be sharing 2 electrons with this carbon. Alright. and hence gaining the benefit of 2 electrons. So now this oxygen has a benefit of 1, 2, 3, 4, 5, 6, 7, 8 electrons, and hence we can say that the valency of this oxygen is satisfied. Okay, are you getting how to count the
Yes.
number of electrons around the oxygen? The 4 electrons which are unbonded, the 2 bonded electrons of the oxygen itself, and the 2 bonded electrons of the carbon, now they are also the electrons of oxygen. Okay, so you have an octet configuration, and therefore the oxygen's valency is satisfied. For this oxygen, if you observe, if you have 2 to 4 to 6, so again it requires 2, so it shares 2 electrons with itself and with carbon and now you can see all the valencies are satisfied. You can see the carbon has got a total of 8 electrons, and each of the oxygen has now 8 electrons along with the shared electrons. Count it. Got it? Okay,
Yes.
now try to make the structure of C2H2. Let's see who can make this. Try to make C2H2. Once you make this, we'll be ending up the class with this C2H2. Try to make the structure for C2H2. Okay, anyone made C2H4?
So made.
Okay. So can you show or tell?
So one carbon will be attached to one hydrogen and it will be in triple bond with the other carbon.
Triple bond with other carbon atom. Alright. So the 2 carbon atoms, they will be held together with a triple bond between them. Right? So see, it will be like this. Every carbon atom, it has to be 2 carbon atoms, and there has to be 2 hydrogen atoms. So the 2 carbon atoms can form one bond with each of the hydrogen atom. No 2 carbon atom can form all the 4 bonds with itself. Okay. So in this way, now there are 3 electrons which are left with each of the carbon. So there they share them among themselves. So in this way, the 3 electrons have been shared with each of the carbon. So the valency of carbon and hydrogen both are satisfied. Got it? Okay, try to make the structure of NH3, ammonia. Try to make NH3. The class is about to end in 2 minutes. Before that, complete this NH3. Yes? Anyone made? Okay, see the answer then. Every nitrogen has 5 electrons, of which it is making 3 bonds with hydrogen. So there are 3 bonds with hydrogen. Hydrogen, hydrogen, hydrogen. And for nitrogen, there are 2 electrons. So which are empty over here. And the 2 electrons, they are empty. Empty means they are not bonding. So now if you see, nitrogen has all the octet being completed. It shared 3 electrons and 2 of the electrons are with itself. Now its total of 6 plus 2, which is 8. So the configuration of nitrogen is satisfied. Alright. Okay. Bye everyone. We'll see again in next class.
Thank you, sir.
Thank you and happy learning.
Thank you, sir. Bye, sir.
Happy Diwali, sir.
Happy Diwali. I
Thank you,
hope
sir. Bye, sir. Happy Diwali. Have a good day.